Okay, so let's take a look at the past tests from chapter one, and we'll work out numbers 5, 6, and 7, which all use the same graph here. So in this one, in number 5, 5 is actually a pretty basic question as long as you understand the notation. So it's saying the first part here says what's f of 2 plus g of 2. And f of 2 is really whatever the y value is when you plug in x equals 2 into f. So here's 1, 2, and if we plug in 2, we get negative 2. So this part right here, f of 2 is negative 2. And then g of 2, when I plug in 2, I get, what is that, 5? So negative 2 plus 5, I get 3. So that's the answer to part A. 5b, I've got, oh, I don't know what happened there. F of 1 times g of 1. So let me use this. So f of 1, if I plug in 1, I get negative 1. And if I plug in g of 1, let's see, if I plug in 1 for x, then g is 4. So this answer is going to be negative 4. 5c, what's that asking for? G of 0 over f of 0. So g of 0, let me clear out this stuff. G of 0, when I plug in 0, I get 3. And f of 0 is 0. So since I'm not allowed to divide by 0, this is going to be undefined. And then 5d, let's see, what's that? G of f of 3. So I'm going to do the inner part first. So f of 3 is, let's see, 1, 2, 3, it's 0. So really what I'm doing is g of 0. And then g of 0 we already figured out in the previous part. When I plug in 0 into g, I get 3. And then 5e, that says g circle h at 4. And then they tell you on the side here, h of x equals that square root function. Well, this is just a different notation for g of h of 4. So if I figure out what h of 4 is, then I can plug that into g. So h of 4, if I use this, I'll just work this out up here. H of 4 is going to be root 16 minus 4 squared. So that's 16 minus 16, so it's root 0, which is 0. So this is really just asking for g of 0 one more time, which is, again, 3. So that's it for 5. Number 6 asks, is f from this graph, the green graph here, is it a function? And so 6, yes, f is a function. And the quick way for answering that, because it passes the vertical line test. Right? Any vertical line I draw only intersects f one time or no times. As long as it doesn't intersect more than once, then it's a function. So then the next part says, is f inverse a function? Well, the way to get f inverse is to switch all the x and y values of f. And so you could say, instead of actually graphing f inverse, what you could do instead is, since inverses are gotten by switching x's and y's, instead of passing a vertical line test, which is of the form x equals some number, where that's all the vertical lines, x equals 1, x equals 2, x equals 3, instead, since we're switching all the x's and y's, instead of switching all the x's and y's for f, just see if it passes a horizontal line test instead. And if it does, if the original graph passes a horizontal line test, then its inverse is a function. And you can tell right here, right, that fails the horizontal line test. So you would say no, f inverse is not a function because f does not pass the horizontal line test. If you wanted, you could actually plot, you could figure out, okay, 0, 0 stays the same. This point, 2, negative 2 on f, that's going to turn into negative 2, 2 on f inverse. You could plot this point on f inverse. and then actually do the vertical line test on the graph of f inverse. But, you know, this is a quicker way of doing it. So, okay, so that's that. And then in 7, the question is, using the same graph for number 5, graph this new function, which I'll call, since we've already used f, g, and h, I'll call it, I don't know, let's do k. So my new function k of x is going to be f of negative 2x minus 1. So this is the new function. And we need to get that from f of x. So the important points on f of x are 0, 0, 2, negative 2, and what's this one? 6, 6. Those are my 3 major points on here, and then they're just connected by straight lines, straight segments. So my original equation is f of x. I need to turn that into k of x, which is f of negative 2x minus 1. Okay, so on my original, a general point that I have is a f of a. And on the new one, I need to come up with something like that. And so the trick, again, is to take the ugly x terms in the new function and simplify them. So this right here, I'm going to call a. And then if I work this out a little bit and isolate the x, I get a over negative 2 equals x. Right? So this is the key to the problem. And so then I could write k of x instead as k of, and then my x is really a over negative 2. And let's see, what does that end up equaling? So that ends up equaling f of what I called a minus 1. So then I can say, all right, so my general point here that I'm going to get from this k of x, which is the same thing as this, is going to be a over negative 2, comma, f of a minus 1. So then you can look at this and say, okay, how do I get from the first point to the second point? Well, I did a horizontal shrink by a half, and then I did a horizontal reflection, and then I went down 1 unit, vertical shift, down 1. So you could think of it like that. But really, I didn't actually need to know the exact transformations. What I need to know is what happens to these 3 specific points, right? So one of my points is 0, 0. One of my points is 2, negative 2. And one of them is 6, 6. So these are my a f of a's on the original graph, and they turn into these guys down here. So in the first graph, a is 0. So that means on the new graph, my x-coordinate is going to be 0 over negative 2, which is still 0. And then f of a was 0, so f of a minus 1 is going to be negative 1. And this point, 2, negative 2, a is 2, so when I plug it into my new point, I get 2 over negative 2, which is negative 1. And then when I plug in f of a as negative 2 right here, I get negative 2 minus 1, so negative 3. And then when I plug in 6 and 6, a over negative 2, when a is 6, I get when a is 6, I get negative 3. And when f of a is 6, this is going to turn into 6 minus 1, 5. So there are my 3 new points on the graph. And so let's see, if I plot those, they'll go over here. So 0, negative 1, right here. Negative 1, negative 3, so negative 1, negative 2, whoa. Negative 3, so 1 point was there. Negative 1, negative 3 goes here. And then negative 3, 5, negative 2, negative 3, 1, 2, 3, 4, 5, up here. And there's the new graph right here. Looks like this. That's really all you need to graph it. So make sure you understand this idea right here in particular. This is going to be the spot where a lot of students have trouble, is turning this into the general point. and then using this formula to come up with your 3 new points from your 3 old points. Okay, hope that helps.